So this problem has 4 parts. The first part says determine which of these functions are injective. For those that are, obtain their inverse, and for those that are not, find 2 points with the same image. Okay, so we have 8 functions here. 2 questions, B and C, related to the functions in 5 and 6, and then D, determine if these 8 functions are surjective and bijective in their domains. Okay, so this is going to be a long problem, but what I'm going to do is to solve A and D at the same time. So I'm going to be determining if a function is injective and if it's surjective and bijective at the same time. Okay, and then we'll go to B and C. So let's start with let's start here. Okay, so first one, f of x is 7x minus 4. Okay, so if you painted this function, this would be something like this. Okay, this would be minus 4. Okay, and then this slope of 7. Okay, for a line. So before I say anything, can you guess if this function is going to be injective and surjective? So the easiest way well, first of all, remember that for a function to be injective, that means if x1 and x2 are different, then f of x1 and f of x2 will be different. Okay, in other words, it means that this function will map every point in the real line to a different point in the real line. Okay, not 2 values will be repeated. And surjective is that for every y, the real line, so every value that we can think of, there is an x such that f of x is y. Okay, so any value that we can think of, that we can find a value x that it's mapped by the function to y. Okay, and when a function is both injective and surjective, this is called bijective. Okay, so the easiest way actually to see if a function is injective or not is to find its inverse. Okay, to go directly to that. So if a function is injective, then for 2 different values of x, then you will have 2 different values of y, which means that you can always find an inverse function. Okay, a function that takes you from this f of x1 to x1. Okay, because the mapping is unique from one to the other. So if there's a function that takes you to x1 to f of x1 and then x2 to f of x2, there's automatically a function that brings you back from f of x1 to x1 and f of x2 to x2 and any other point. Okay, so this is what we're going to do here in almost every part. So yes, so we want to find a function f minus 1, the inverse of f, that takes us back. So the way to do this is, if we have this equation, okay, now we want to solve for x. Okay, so now here y is in a sense the unknown. Okay, if we plug any value here of x, then we will have a y. Okay, so we want to have a function, an expression, so that we plug values in y and then we have a value of x. Okay, so we want x to be alone, in one sense. So this is simple algebra. You just sum 4 to both sides and then divide by 7, so you have x is equal to y plus 4 divided by 7. Okay, so this means that for every x that we have, we will have a unique y, okay, given by this expression. And if we plug a different x here, you will have a different y, okay, and the other way around. So this function is injective. Okay, there is only one solution So given one y, there is only one x. Okay, you can see this. But there's more to this, because this equation holds for every y. Okay, it doesn't matter which value of y you write here, from minus infinity to infinity, going to every real number. There's always going to be an x that maps to it. Okay, so this means that this function is surjective. There's always a solution to this equation. Okay. And you can see that in the graphical representation. Okay, a line goes all the way to minus infinity and all the way to plus infinity, and there's always only one point that corresponds to a given value. Okay, so if you pick this value of y, then only this value of x will map to it. Okay, any other value will map to different values of y. Okay, so that means this function is bijective. Okay, fair enough. Okay, let's go for second. So we have f of x is the sine of 7x minus 4. Okay, so, well, if you know anything about sines and cosines, you know that the sine looks something like this, and like this. Okay, so it's obvious that this function will not be injective. Okay, because every other point you get, for instance, the value 0, you get it infinite times, and the value 1 and the value minus 1. Okay, so this function is periodic. That means that it repeats itself. So every period you get a copy of the same function. So the same x plus the period will give you the same y. Okay, so in other words, if we have a given x1, okay, if we write x2 is x1 plus 2 pi n over 7, okay, when you plug this here, you have f of x2 is the sine of 7x1 plus 2 pi n minus 4, which is the same as the sine of 7x1 minus 4, okay, because the period of the sine is 2 pi. Okay, so here n is a natural number. Sorry. So if you plug 0, so 1, 2, 3, whatever, any natural number will give you the same value as this one. And this thing is exactly f of x1. Okay, so we have two different values of x, x1 and x2, that give us the same value of x, of f. Okay, so this means that this function is not injective, but it's also not surjective, because the range of the sine is just this interval from -1 to 1. That's the range of the sine. So if you wanted, for instance, to write a 2 here, so 2 is equal to this, there's no value of x, no way that you can find an x that plugging in here gives you 2. Okay, there's no solution for that. So that's why the function is not surjective. Okay, and because, well, it's not injective, not surjective, obviously it will not be bijective. Okay, is this clear? I hope it is. Now let's go for 3. So we have f of x is x plus 1 cubed plus 2, and again we want to, if you write this like this, this is a value y, and we want to solve for x. Okay, so that given then a y, let's see how many values of x we can find a solution. Okay, so we subtract -2, then take the cubic root of both sides, and then subtract -1, so you have So again, this expression given one value of y is unique. It will only give you one x. Okay, so the the cubic root is also an injective function. So this function will give you only one value of x. So this function is injective, but it's also surjective, because it doesn't matter which value of y you plug in here, you will always have a solution for this equation. Okay, so this expression makes sense for every y. Okay, so there are cubic roots of negative numbers. Okay, so every number that you plug in here will have a solution, an outcome. Okay, and so you will find an x for that y. Okay, so again, these two things. So this is bijective. Okay, you see how this is going? Okay, so 4. F of x is x plus 2 over x plus 1. And again, we want to find an expression for the inverse. Okay, so what we're going to do is, let's see. Yeah, we're going to multiply this by x plus 1. So obviously this x can't be minus 1. Okay, the domain of this function does not include minus 1, but you have then y x plus y equals x plus 2, and then you have, if you take x here, so this is y minus 1 times x, and then 2 minus y, so x is equal to this. Okay, so again, provided that y is not 1, so y can't be 1. If y is not 1, then this expression is unique. Again, there's only one value of x coming from this. Okay, there's no way that you can find more values of x for given one y. Okay, so this function is injective. There's only one value of x for every y, but it's not surjective. Why? Because, well, you can't, the function can't map to 1. Okay, so this function is actually something like this. Let's see. Sorry, yeah, I made a mistake. So this function has a vertical asymptote at -1, so that means that there's no domain here, and it has a horizontal asymptote here. So unless this is 1 minus, yeah, you could write f of x as 1 x plus 1 plus 1, and then x plus 1, or in other words 1 plus 1 over x plus 1. So yeah, so this function is like this. Well, I'm really bad at plotting. Okay, so this function goes like this, and then goes like this, and this is -1, and this is 1. Okay, so it has a vertical asymptote at -1 and horizontal asymptote at 1. You don't need to worry about this yet, but we will learn to deal with these functions in the future. Okay, so this function is not surjective, because if you want to choose y equal 1, there's no value of x that will give you this value. Okay, if you go to infinity to x, if you give greater and greater and greater numbers of x, you will see that the values that you get back are closer and closer and closer to 1, but never get to 1 actually. So that's why this is not surjective. Okay, and also I just realized, so the question asks us to find the inverse of a function. Okay, so for both those functions that we have done it, this is the inverse actually. So if we write it like this, you can write it f of minus 1 of x is 2 minus x minus 1. Okay, you just need to change the names of the variables. Okay, but the idea is this. Okay, so f of x is the function that maps this x to a y. Okay, so x gets mapped to this. Now the inverse maps this y back to x. Okay, and that we have solved this. So this is what how to write it. Okay, so if I give you any x, I get you f of x, and then this f of x I plug in here, and then I get back my original x. Okay, that's the idea. Okay, so I'm going to stop here and then continue in another video.